Hi everybody, welcome back to this channel. Today we'll be continuing the final chapter for this portion, which is the scientific endeavor, and we'll be discussing more on the use of a Bunsen burner. So a Bunsen burner is used for heating in the lab. So for those of you who do not know how a Bunsen burner look like, this is how it looks like. So we actually use it mainly to heat items or heating. Okay. Where would the fire come from? The fire will usually come from the top here like this. So this is where the flame is like, okay? So this is the fire. I would say the flame, I wouldn't say fire. Okay, the flame. Now, you are required to first understand the different parts of the Bunsen burner. So what we have here is actually the barrel. The barrel is this column that allows the gas to be flowing up such that the flame will be up top, at the top. Now, in order for this whole barrel to actually take place, there are also other components, which you have the collar. Okay, then we have the air hole. The air hole is highlighted in purple. Then we have the gas inlet. The gas inlet actually allows gas to actually enter into the Bunsen burner. Then we have the needle valve. The needle valve is this particular component here to control the amount of gas flowing up and hence adjusting the height of the flame. And lastly, we have the base. So this base is mainly to support the whole Bunsen burner and to prevent it from actually flowing down. So for this barrel, right, so the barrel is whereby the gas and plus the air is able to mix. Why? Because the gas comes from the gas inlet. So this is where the gas is, and over here, air enters. So you can see that inside this particular barrel, it has a mixture of gas and air. And by adjusting the collar, you are able to actually control the opening of the air hole. So having more air rushing into the air hole, there is actually more flame. The flame is able to burn better and therefore it will be more hot. Why? Because air contains oxygen. So, and we all know that oxygen helps to combusting it helps to burn even greater. So that is how we control. And of course, by closing the air hole, there is still gas present which allows burning to take place. However, this flame would actually change color, which we will actually discuss more later on, and it's not necessarily that hot anymore. Okay, but still hot enough to burn you. So you have to still be careful. Next, the needle valve helps to regulate. It helps to regulate the amount of gas entering the Bunsen burner. Okay, so it helps to control the height of flame. Okay, so this is another one. And then next we have the gas inlet. The gas inlet is basically usually connected to a tap, the gas tap. And the gas tap would then be the supply of gas. Okay, so that is what the gas inlet is for. It allows the gas to actually enter the Bunsen from a gas source. And last but not least, the base helps to support the Bunsen burner. Now, if you close the air hole fully, you will have two kinds of flame. Okay, two types of flame. You would have the luminous flame and the non-luminous flame. So the non-luminous flame tends to be bluish in color, whereas for luminous flame, it tends to be orange, an orange flame. So this is how we go about differentiating, and this is controlled by the air hole. So let me label here as non-dash luminous flame. This is also required in exam, so do take note of the difference. Okay. Not blue, sorry. Non-luminous blue flame for better coloration, luminous yellow flame. Okay, now when you close the air hole, so when you close the air hole, so let's say the air hole is here, you close it totally. No air can enter. So by closing it, there is no air entering the Bunsen burner, and without any air opening, so no air. Okay, due to the lack of oxygen in the Bunsen burner, this flame would actually become more visible, okay, that you can see. So the meaning of luminous means bright. So luminous flame means you are able to see the flame, and this flame is generally not suitable for heating. Now, why is it so? Reason being is because it will generally produce a large amount of soot due to incomplete combustion of flame. And why is it incomplete combustion? Due to the heat source. The heat is actually not hot enough. So this one is lower heat lah. Okay, so that's why it's not that suitable. On the other hand, when you have the air hole right open, that means you open the air hole, it opens, air will enter, and with air entering, your flame tends to become hotter. And why? Because the gas burns with sufficient amount of oxygen. And in this case, when there is sufficient amount of oxygen, what will happen? There is higher heat, making it more suitable for heating. And generally, when this were to happen, it's very hard for you to see the flame. And this one, when you cannot see the flame, right, it's quite dangerous. Okay. Now, the inner walk of the flame, there's also two main parts. There is the outer core, the outer non-luminous core. Okay, these two is the outside, and then the inner. The inner is the one inside here. This is the inner core, which is very hot. Now, where is the most hot region which exam likes to ask? Is the tip here. This is where you will want to put the Bunsen burner. Not Bunsen burner, your test tube when you do heating. So this is the hottest region. Okay, for the respective flame. So the size of the air hole helps to determine the type of flame produced, and to avoid a strike back, ensure that the rubber hose are always attached tightly to the gas outlet and the Bunsen burner. So then, which flame should you want to start a Bunsen burner? Always, it is subjective. So if you want to see where the flame is, right, you close the air hole and you light it. But that itself is also quite dangerous. Why? Because you are not letting enough oxygen to actually flow in through. So it's very hard for you to light the Bunsen burner. So my suggestion is open the air hole, make sure that your hair or face is not directly facing on top of the Bunsen burner, and then you strike, and you strike multiple times. Then after that, when the flame is there already, you control the air hole to allow you to see the gas height, and then you adjust the gas tap. And then later on, reopen the air hole again, because you want the flame to be at its hottest for you to do boiling. So these are some safety precautions. Should there be a strike back? Strike back is where within the air hole, you would see a tiny flame, but at the top there isn't any. By the top of the barrel, there is no flame. It's actually located at the air hole. Do switch off your gas tap. Check that your rubber holes are tightly fitted at both the gas outlet and at the Bunsen burner. Then redo the steps again. If it's still in this manner, close the tap, raise your hand and call for a teacher. Okay, there might be something wrong with your Bunsen burner. Okay, with that, I've come to the end of this section. So do remember to understand the structure of the Bunsen burner, the types of flames, and then I think you will be more or less done for this chapter. Okay, so remember to subscribe to my channel, like my video, and I'll see you in the next chapter. So for this particular series, I am trying out a new method of visualization, which is sketch note style, where you would see that it is more towards of giving you an idea of this summary of this chapter, and hopefully is able to put in some of the key points that you will want to help you to understand your work. Okay, if not, that's all. Thank you.